Okay, this video for AP Physics 1 kinematics test review. Number 1. An object moves around the circle path radius r. The object starts from point A and goes to B and describes the arc of the half of the circle. And which of the following is true about magnitude of displacement and travel distance? So the situation is it travel from A to B like this. Okay, so question is, what is that total travel distance? So that's half of this circumference. Okay, but what is the displacement? Displacement is a straight from final point. Okay, that's a displacement. So displacement should be then diameter, which is 2r, and then a travel distance is a semi circle perimeter, which is a 2 pi r. 2 pi r divided by 2 will be pi r. Okay, so distance travel is this. Okay, and then displacement is this. So answer B. Number 2, a rock is thrown straight up from the edge of the cliff. So let's draw the diagram. So there's a cliff like that, and then you throw a rock straight up. Okay, and the rock reaches the maximum height 15 meter above the edge. So that's a 15 meter right here. And then it falls down to the bottom of the cliff 35 meter below the cliff. So that means that this is 35 meter. Okay, so this falls back down to here. That's the situation. Now, what is the travel distance? So travel distance means going up and going down. So all of them. So you just simply add 15 plus. What is this from the maximum height to the falls back down to the ground? Is you add the 15 plus 35, which is a 50. So 15 plus 50, 65 meter is a total distance travel. D will be answer. Okay. If they ask you what is a displacement, then you should say 35 meter. Number 3, rock is thrown straight up from the edge of the cliff. Basically same description as number 2. The rock reaches the maximum height 15 meter above the edge, and then falls down to the bottom of the cliff 35 meter below the cliff. What is the displacement? Okay, they ask now displacement. So like I said, only thing difference between initial position and final position. So displacement basically final position minus initial position. Initial position. Okay, that's how much it changed the position, which means the displacement. So that is 35 meter. Okay, there's a difference, total distance travel and displacement. Number 4, can an object's average velocity equal to 0 when object speed is greater than 0? What's the difference between speed and velocity? Speed is a magnitude. Okay, and velocity is a vector. Vector, it has a magnitude and direction. So speed, you cannot have a negative value. Speed is only magnitude. So basically, absolute new velocity will be speed. Okay, that's how you're gonna tell. Okay, so is that possible? Answer is yes, that's a possible. So you can imagine. So let's say this one going to the right here. So let's say initial velocity, it was like 10 meter per second. Okay, so positive means positive velocity going to the right, and then negative velocity is going to the left. So this one stop and then like going back all of a sudden. So then like V final is less than negative 10. So your average velocity, okay, average velocity means V initial plus V final divided by 2. But this one is a 10 plus a negative 10 over 2. So it will be 0. Okay. But what is the speed, right? Speed for that time. So absolute of your V final, that's a speed, right? So then absolute negative 10 is 10. So it could be greater than 0, but velocity, average velocity could be 0. Okay, so answer is a yes. And then object returns to original position. So then answer B. Number 5. A car accelerates from rest to a constant rate. That's acceleration. Which of the following statement is true? Okay, so if you understand what is acceleration means, it increases the velocity because it's positive, not decrease. Every second, 5 meters per second. So C will be, that's the basically definition of your acceleration. Okay. Now let's look at the graph here. An object is thrown straight up with the initial velocity v naught, and the graph represents the object's vertical displacement as a function of time. Use the graph to the right for question 6 through 8. What time total flying time object? So when it hit the ground here is 8 seconds, so D. What time object reaches the maximum height? So that's the maximum height right here. So that time is 4. Okay, it's not hard. Now, what is the initial velocity? Okay, that could be hard. But if you understand, those are key formulas for 4 formulas. If you watch the other kinematics video, I talk about those formulas you need to know. So you can watch that one again. Now, what is the initial velocity v naught? Then one of the formula you can use is your height is v naught plus 1/2 v naught t at squared. Okay. Initial position 0, so I didn't put it there. Now, so when it touches the ground right here, right? So your height is 0, so 0 when it touches the ground. And initial velocity, that's what you're looking for. And then 8 seconds later, okay, it'll touch ground. And G, A is a G, the gravity, which is a negative 10. So 1/2 times a negative 10 is a negative 5. T squared is A squared. Okay, so from here, only unknown is V naught, so you can find out initial velocity. So 8 V naught equals 5 times 64, 320. So V naught is 40 meter per second unit. Okay, so number 8 is a B. Number 9, which of the following graphs represent a velocity as a function of time of the object thrown straight up? So this one is about velocity versus time. So x-axis is time and velocity is y-axis. So now this one, you can tell velocity for this one. So initially, when you throw something straight up, that means your velocity is some positive value. So it cannot be like this. This is a velocity 0, but initially should be some positive. And then so imagine, so you throw something up and then it'll stop and then it comes back down, right? So then initially some positive value, so this is correct. And then that makes sense because only acceleration is gravity, which is a negative 10 meter per second squared. So your slope keep going down, right? And then certain point, so that time is your velocity is 0. So this one is when it reaches a maximum height, right? Reaches max height. Then your velocity is 0, and then now it becomes a negative, right? Because it falls back down to ground. So answer C for the number. Now, which of the following graphs represent the acceleration? Now, this time, acceleration versus time. So your x value is a time, and this time here is acceleration. Your acceleration, what acceleration do you have when you throw a ball in the air? Only acceleration you have is gravity. Gravity is a negative value, so answer is always a negative 10 here. Okay, so in the, let's say this on position, so when you throw a ball and it goes up and it goes back down, so your acceleration is always the same no matter where that is. Okay, so their gravity is a negative 10, okay, meter per second square. The relationship between position time of a moving object is shown the graph, and then use this graph for questions 11 and 12. What is the instantaneous speed? Okay, object at 4 seconds. So where is a 4 second located here? So go up here. So that one. This is a position. So your slope will be instantaneous speed. Okay, what is the slope there? So that moment, so that's like rise over run. So 8/4, which is a 2 meter per second. That's the that moment when it reaches a 4 second. Then speed is should it be 2 meter per second. Now number 12. During which of the following times does the object accelerate? So it shows accelerate means basically so if it is on position and time, slope, okay, slope is a velocity. Okay, acceleration is we call concavity. Okay, concavity means if it's go open upward, then that's concave up, which means it's a positive. Okay, so your acceleration positive. If acceleration negative, then concave down, like that. So the question is during what time the object is accelerated. So if this one slope is a 0 and there's no concavity here, right? So then you don't have any acceleration right here. But I see that here open down. So you have your acceleration here is negative certain value. Okay, so you see that after 4 to 8, then there's an acceleration. So acceleration is a negative value because it's open downward. Okay, that's how you're gonna tell. Now, graph to the right describes the relationship between velocity time for the moving object, and I use this graph for question 13 through 18. Number 13. What is the acceleration time? So this is you have to notice the previous one was a position, but this time is v versus time. So slope of this graph will be acceleration. So keep in mind, slope of this one is acceleration. So what is the acceleration? What is the slope at t equals 1 right here? At t equals 1. So slope is 2/1, so 2. And then it's going up, so positive 2 meter per second square. Okay, so remember that. So let me write down here. Slope of vt is acceleration. Okay. Now, what is acceleration then when t equals 8? T equals 8 right here. So you see that slope is a 0 there. So 0 meter per second square. 15, acceleration t equals a 6 right here. That slope is negative 4, right? So negative 4/1. So negative 4, c. Now, what is the total displacement entire trip? So displacement is if it's a VT graph, then area under the curve. Okay, so this area here, and then you subtract this area. So below x-axis, so negative area, and above x-axis, that's a positive. Okay, so area under the curve will be displacement for the VT graph. So remember that. So how you gonna find out this area right here? That's the area of trapezoid, so 1/2, Let me write down. Area of trapezoid is 1/2 base 1 plus base 2 times height. Okay, you need to know that one. So base 1, let's say this one is a 3 and this one is a 6. Okay, and height is a 4. So 3 plus 9 times a 4. So then 12 times 2 is a 24. Okay, 24 meter up there. 3, 6, and then hold on. So that's a 12 times 2. Yeah, 20. 24. Oh no. So I made a mistake here. So 3 plus a 6, basically not 9. So that's a 2 here, and then so 18. Okay. Now here, so same formula, 1/2. Base 1 here is a 4, and base 2 is a 2. Height is also 4. Okay. So base 1, 2 plus a 4 times height. Make sure you put negative. Okay, because underneath the x-axis. So this one is a 6, negative 12. Okay, so that area is a negative 12. So what is the final total displacement? So you subtract, so 18 minus 12, which is a 6 meter, is your answer. That's the displacement. Number 17, what is the total distance traveled? Total distance traveled means it's always you make it positive displacement for each. So this one is positive 18 and this is also positive 12. So total distance traveled is 18 plus basically epsilon negative 12. So that's 18 plus 12 is 30. 30 meter is total distance traveled. 18, between what time does the object approach the origin at the constant speed? Okay. Approach origin at the constant speed. Constant speed, where is the constant speed located? So if you look at that, this is, remember VT. So I see that constant speed here, constant speed here. But which one is answer for that? But this one is approach to origin means if it's a positive velocity, it's away from the origin, right? But it's approach to origin, that means it shows that that's a negative. So negative constant velocity is basically here. Okay, so answer is a 7 to 9. So 7 to 9 will be answer. Number 19, a rock is thrown straight up with twice the initial velocity of another. So how much higher will the first rock at the apex? Okay. So what happens if your initial velocity is twice? So you can think about formula first. So then what formula you can use this one? So your initial your final velocity, one of the formula we talk about is this one, 2a, and this distance, but you can say height. Okay, for that one. Now when you throw, and then there's an initial velocity, but when it reaches the maximum height, which is apex is a maximum height, then that time your velocity is 0. So you can say 0 equals to velocity, initial velocity square plus 2 times gravity is a negative value, so negative g h. So you can say height is basically 2gh equals a velocity square. So you can say your height is velocity square over 2g. Okay, so that's the formula I derived. Now, so what happens if it's a twice initial velocity? So let's plug it in. Twice initial velocity. Okay, so 2g is the same. Then that you end up with then 4v naught square over 2g. So that means this one is compared to this is 4 times. Okay, so your height will be 4 times of the previous one. If your velocity is twice, then your height will be 4 times. Okay, so use that formula. Number 20, a student drop a pebble from the edge of the vertical cliff. The pebble hits the ground 4 seconds after it was dropped. What is the speed of the pebble just before hit the ground? So what formula would you use this one? So you can use the same formula as before, that one. So V final square, V initial square plus 2A height. Okay. So then, when it drop, initial velocity this time is 0. Okay. You're looking for final velocity when it hit the ground. And so now, what is the height then? Right? How are you gonna find out your height? So what you can do, you can use this way. Your height of t, initial height plus a v naught t plus 1/2 at squared, right? Using that one of the formula we talk about. We talk about the velocity and acceleration for y direction, keep in mind. So you just drop it, so that means initial velocity, you don't have it. When it hit the ground, height is 0. And then what is the initial height, right? So then you can find the height from that equation. And a is a gravity, so -10. So 1/2 of -10 is a -5 t squared. Okay, but 4 seconds after you hit the ground, so your height is 5 times the 4 squared. So 16 times 5, so 80 meter. So I'm gonna substitute. So remember, we are looking for your speed in this equation here. So your final velocity is a square root of 2 times -10. Okay, your acceleration is that, and now height is 80 meter. But you might wondering how you're gonna have a negative inside the square root. So you can say in this case, positive, make it positive. Okay, we need to know just like for magnitude for that. So when you multiply it out, 1600. Okay, then that's a 40 meter per second. When it hit the ground, it'll be 40 meter per second. Okay. So I use two formulas basically. One formula is this, and then to find the h, I use this one. Okay. So in order to do that, you can find out your answer. Now, number 21, a student drops a pebble from the edge of the vertical cliff. The pebble hit the ground 4 seconds after it dropped. So it's basically similar to previous question. But what is the height? We already found out the height, right? So using that one, so it was 80 meter. So answer is a T. Okay, we already talked about it using that equation. Number 22, astronaut on the moon simultaneously drop a bird feather and screwdriver. Okay, of course, for the feather is a lot lighter in terms of math, in terms of their weight. Now, the fact that two objects reaches the surface at the same time, so it actually reaches the same time like that, as long as they have a same math. I mean, it doesn't have to be same math. As long as they're same height, then it will reach the same surface on the ground. Now, can be explained by what? Why it reaches, even if it's different math, then how come it reaches at the same time? Then that can be explained by, answer is this one. The given location, okay, same height when it's a fall, because acceleration of that object is basically same, right? So, and the moon is, of course, it's not like same as Earth. It's not like -10. It should be a little less for that. But then also we consider the absence of the resistance. So you ignoring air resistance, then it will reach the ground at the same time. Okay. The reason why, if you think about it, what equation you can have? So that's h of t equals h naught plus v naught t plus 1/2 a t squared. So you think about this formula here. And then initial velocity when you just drop in the same height, okay? So the situation is here. So there's a feather and you have a screwdriver, right? Screwdriver like that. And then when it's same height and then when it drops, then it hit the ground at the same time because initial velocity is 0 and this one is not negative 10 but like negative certain value, okay? Then your height is the same. So it'll actually reach the at the same time for this one, okay? The other value is exactly the same. Now number 23, next one. Marble launcher shoots the marble horizontally from the height of 0.2 meter above the horizontal floor. The marble lands on the floor 5 meters away from the launcher. So how long the marble stay in the air? So what happened is there's a table and then the marble is shoots this way and then it'll hit the ground, right? So this one is that height is 0.2 meter above the horizontal floor. And then this one is 5 meters away. It'll hit the ground. So then what's the time, right? When it hit the ground, what is the time? That's the question. Now, you can use the other formula we talk about. So like height is your initial height plus v naught minus, I'm going to say just 5t squared because we know the gravity is negative 10 instead of 1/2 a t squared. So you can write this way, t. Now, you're looking for time. So when it hit the ground is 0 and the initial height is 0.2 and of course the vertical velocity is 0. So negative 5t squared, so you can find out t. So 5t squared equals 0.2. So t is a square root of 0.2 over 5. So when you plug in the calculator, 0.2 divided by 5. So I got 0.2 second. 0.2 second later, it'll hit the ground. So answer should be B. Number 24, a marble launcher shoots a marble horizontally from the height of 0.2 meter above horizontal floor. It's basically the same thing again. The marble lands 5 meters away, so that's also same description. And what is the initial speed? Okay, so they ask you what is the initial speed. Okay, but keep in mind it's not 0 because this one is we talk only vertical speed there, but there's a horizontal initial speed they talking about. So what we know is that horizontal distance travel is 5 meter. Okay, then your initial speed, that initial speed is a horizontal speed. That time is a time. Time is a 0.2 second. So from here you can find out horizontal initial speed 5 divided by 0.2. So you get 25 meter per second. That's the initial speed when it launches the launcher. Okay, from the launcher. Now next one, number 25. A bicyclist moves along the straight line with the initial velocity v naught and slow down. So which of the following the best describe the sign set for the initial position, initial velocity, and acceleration? So initial velocity, since is this vector moving to the left, okay, so it's then toward to the left. That means that this is a negative. Your inertial velocity should be negative. Okay, but it says slow down. Slow down means, remember, whenever you see slow down, that means your velocity and acceleration are opposite sign. Okay, if it's speeding up, that means velocity, acceleration should be same sign. It doesn't have to be positive. It could be negative, negative. That means for the negative side or downside, it's speed up. Remember that. So now this one we know slow down. So it's a velocity was a negative, so should it be positive? Okay, not this one. So you already know 25 is a C. And then initial position also negative here. Is that? So answer is a C. Number 26. Which of the following is a vector quantity? Okay. Vector is basically only displacement, not total distance travel. That is just a scalar value. So that's like absolute value. So it's not. Area is not a vector. Mass is not a vector. But weight is a vector. Okay. But mass is just quantity. So that's not a vector. So displacement, yes, that's a vector, and then we put it final position minus initial position. It has a magnitude and direction. Now, which of the following, number 27, is not a vector? So we just talk about it. Travel distance is not a vector. It's just quantity, okay? How much distance it travel, total. So, but the other one is velocity, displacement, and momentum. All of them. We're gonna talk about that momentum later, but that's the also vector quantity. Now next one, a vector displacement d is a placed xy coordinate plane system shown in the diagram to the right, and I use the diagram to answer the question 28 through 30. Number 28. What is the x component of the vector d? What is x component? So x component of that, so right here, and y component is right here. Okay, so x component is 3 meter. Okay, answer B. Now, what is a y component? So like I said here, y component should be 4 meter. Now, what is a magnitude? So if you remember in geometry, you don't have to use the Pythagorean theorem, then 3, 4, 5. Okay, 3, 4, 5, then should be magnitude, that one is a 5 meter. So I use triples, 3, 4, 5. Okay, it's a lot quicker. Now here, next one. An object changes the velocity from v1 to v2 during a time interval delta t. Which of the following is the correct direction for the acceleration? Okay, so how you gonna draw this? So basically, to go to that direction here, your acceleration should be then this way, right? This way, because initially it was going this way. Okay, and then to go up, then your acceleration should be like basically this way. Okay, to be like this, then acceleration should be this way, then it'll go up. So answer is B. Number 32. Now, a projectile is fired 60 degrees above the horizontal line with the initial velocity v0. At which of the following angles the projectile will land at the same distance as it is landed the first trial? So they ask you with the 60 degrees angle and with what angle will land on the same distance, like same distance right here. So one way I want you to remember is always complementary angles. Okay, it's good to know. Complementary, add up to 90. Complementary angles will land on the same distance. So complementary of 60 is a 30, so answer is a B here. Well, why is it like that? And then this one, so think about it. Maximum is a 45 degrees. Okay, to go maximum farthest away is always a 45 degrees. It's good to remember. But 60 and then 30 degree, they end up with the same distance. Like let's say 80 degrees angle, then 10 degrees is also same distance you're gonna land. Okay, because they are complementary angles. But maximum height is a 45. Maximum range, I'm talking about this range. maximum range is 45 degrees angle. So if you're wondering like why it's like that, then I also remember this range formula. Range is a v squared times a sine 2 theta over g. So that's the formula I want to remember this. That's a projectile. Okay, projectile. When you fire with some angle, then that's this is range, how far away it'll go. Okay, and this is height, and that's the formula. So basically, if you think about it, so only angle involved here. So let's say theta is a 60 degrees, right? Then sine 2 times 60, which is a sine 120. If you remember trigonometry, sine 120 located here. Okay, and then using that reference angle right here, 180 minus 120 is a 60 degrees. So that's basically same as a sine 60. And then sine is also positive, right? Quadrant 1, quadrant 2, if you remember trigonometry. I'm talking about all students take calculus. So if a terminal side located quadrant 2, then sine is also positive. So sine 120, same as sine 60. What is a sine 60? That's a sine of then 2 times 30 degree. Okay, so that means your original 60, you got same value as a 30. Okay, so remember that. So that's how you see it. So my conclusion is complementary angles is always the same range you're gonna get. For those who wondering where this formula coming from, let's talk about this one in here. So let me derive it. So derive formula. Okay, so we talk about the formula R equals your range for x side, b squared sine 2 theta over g, and at the same time I want to talk about also h is another formula, which is v squared sine squared theta over 2g. So this is a formula, good to know. If you memorize this, then it'll be very helpful. So how are you gonna derive that? So let's talk about it. So from A position, so this one is projectile, so with some angle, okay, and then initial velocity, let's say v. Then you can break down that this one is a vy, and this one is a vx, because velocity is a vector, so you can separate into two vectors. One is horizontal, one is a vertical. And then it'll go up here all the way, and then it'll come back down to the this, let's say, position right here is a B, and when it hit the ground is a C, let's say C, and that one is, that height is H, and this is R range. So from A to B, so you use this formula. So your velocity, but in terms of y, okay, v final equals v initial plus at. Okay, so then at b here, your velocity will be 0. Okay, I'm talking about vertical portion. So vertical velocity equals 0 at the highest position, and initial velocity that's basically on the y portion is this by is a v sine theta, right? So you can say v sine theta, and then this one is a is acceleration, so gravity minus gt. So you can isolate t here, so gt equals to v sine theta. So your time is, when it reaches the maximum height, v sine theta over g. So leave it like that. Now, so then we found out when it reaches here, the time is this. What about it when it comes down? How long it'll take? So from here to here, so same time. So this, how much it'll take here? The same time it'll take from here to come back down here. So just simply, that moment, the time is twice 2v sine theta over g. So it'll take that time. So we put it this one here. Now, another one we're gonna talk about is, let's say then, in terms of using this formula, v final square equals v initial square plus 2ad, right? Now, when it hit the ground, so I'm looking for now is h, okay? How are you gonna derive this formula? So when it hit the ground, basically the velocity will be 0, okay? So 0, and then your initial velocity, that one, so then v sine theta square, and then minus 2gh, okay? d is height, and then a is gravity, so negative g. So from here, 2gh equals v square and sine square theta, okay? So your h is v square sine square theta over 2g, okay? So that's the formula up there. That's how I'm going to derive it. Now, I'm going to find out the range formula here, how far away it'll reach, right, when it hit the ground. So then you can say, since we know already time right here, so your r is a vx times t. But remember, horizontal portion is a v times cosine theta. Cosine theta. Times a time is, I'm going to copy that, 2v sine theta over g. So you end up with v square, and then I'm going to reorder this one, 2 sine theta cosine theta over g. And then if you remember in trigonometry, this is a double angle formula for sine. So v square sine 2 theta over g. So that's how I'm going to derive for your range, right? So that's right here. Okay. So for those of who want to know like how get those h value and r value, those formulas, so I derive it here for you. So for your reference. Now let's move on. Number 33. When a projectile reaches the highest point, the vertical component, what is acceleration? So acceleration, you have only one acceleration, which is gravity, throughout entire projectile, right? So that's a negative g always. Okay, so your gravity not gonna change it. Number 34. When a projectile reaches the highest point, then horizontal component of the acceleration, you don't have it. Okay, acceleration is only gravity, which is a vertical component. It act the downside, right? Number 35. Object is thrown horizontal with the initial velocity this one, and from the roof of the building, 40 meters tall. So how much later does it hit the ground? So what happened is here, so 40 meters above, and then when it throw the ball object, then it'll reach the ground right here. But that one is how much later? So what time it'll hit the ground? Okay, so then you can do this way using this formula. So h of t, h naught plus v naught t minus a 5t square. I'm going to just say it this way. And then this is a vertical velocity 0. So when it hit the ground 0, and then it was the initial height 40 minus a 5t square. So you can find out t from here. So t square equals 8. So then t is root 8 second. So c, root 8 second later it'll hit the ground. Number 36. Object is thrown horizontal with the initial velocity 10 from the roof, 20 meters. So how far it'll hit the ground? So this time there's different height, which is 20 meter. Also your initial velocity is basically 10 meter per second. And then how far away it'll reach here. Okay. So what you can do, you can use first of all kind of same formula. So I'm gonna just use the form I used here. So 0 equals initial height is a 20 this time, and then 5t square. So t square is a 4, so t is a 2. 2 seconds later, it will hit the ground. But what is your horizontal velocity? 10, right? So your, let's say this on range here. So your range is horizontal velocity 10 times time. So 20 meter, it'll go. Okay, that's how I'm gonna do. Now the diagram to the right represents the swimmer. The swimmer is capable to swim in still water, V1, 1 meter per second. So this is a 1 meter per second. And he aims his body directly across the 100-meter wide river, whose current is this velocity is 2 meter per second. So this is 100 meter across the that river. Use the diagram to answer. Okay, 37. How much time it will take for the swimmer to cross the river? Okay, so then what you can do is basically that's 100 meter, and in a still water, you can do 100 equals your velocity is a v1 times a t. So this is a 1 meter per second, so it'll take 100 seconds in a still water. Okay, now how far the downstream will he land? So they ask you how far away is here. So they ask you how far away downstream. So then this is a speed times a time. So this one, so you can say your distance is 2 times 100 seconds later, right? So then it's basically 200 meter. So this one, it will go 200 meter downstream that way. So it's 200. Now, what is the velocity of the swimmer relative to the bank? So then this way is a 1 and this way is a 2. Okay, and then what is that speed? Then you can use the Pythagorean theorem. So this speed is root 1 square plus 2 square, so root 5 meter per second. Okay, so that's the answer. Number 40. The graphs above represent position, velocity, acceleration as a function of time for a marble moving in one dimension. And which of the following could describe the motion? So if you think about this is position here, S of t, then you see that this one going down here, and then start from here going up, back up. And you can see from the gravity, let's say there's a rolling ball, right? So this one is keep going down, and your velocity is going this way. The slope is going negative, and now increase, and then that time is your slope is right here, 0, and then slope is a positive now. So it used to be negative certain point, and then going up, and then this point right here is that point here. So slope is a 0, and then now slope is a positive, so going up. Okay, and acceleration is only gravity here you have, so certain negative here. So that means that matches with B. Okay, rolling down one side of ball and then rolling up the other side, and then only acceleration is gravity. Number 41. Position as a function of time and moving object is represented by the graph. So this one xt graph. Now, which of the following is true about the type of motion? So this one, you have a slope is a positive, right? Because going up, positive constant velocity. So only thing matches. This is also this one, and also slope is equal to object velocity. So you can choose both of them. Okay, actually both should be correct answer. Positive velocity and the slope itself is a velocity. 42. position as a function of time of two objects is represented by the graph, and which the following statement is true. So one thing I noticed is that velocity is a steeper is a bigger, greater velocity. So object 2 has a greater, yeah, so B is a true. Now at time t naught right here, so then it's the same position, means that they're gonna pass. Okay, so B and D also answer for that. Now next on 43. Projectile is a fire from the ground level and with the initial velocity is V naught, and which of the following is true? Let's see. Vertical component is V naught sine theta. Vertical component velocity at C. At C here, vertical component of the velocity is actually 0, right? At that point, right? Because that's the maximum height, so you don't have a vertical velocity. Horizontal component of is a, yeah, that's original, same as this one, V naught cosine theta, so that's true. Projectile travels with the same speed, B and D, so it's the same height, then your speed wise should be same. Okay, your velocity here, velocity back down should be same, so C also true. Acceleration at C, no, acceleration is gravity, so always negative 10, so it's not 0. Okay. Number 44, next one. An object accelerates from rest at constant rate, and which of the graph could be used to describe the motion? So this one is a xt graph. And I said accelerate from rest. So you can see so this is could be answer because slope of the velocity is acceleration, so that's some constant, right? And then this is also acceleration graph, so that's also some constant, positive constant. So B and D could be answer for that description. Okay, it's at the accelerate constant rate, so it could be both. Now number 45, that's the last one. Tennis ball is thrown straight up and caught the same height, and then which of the following can describe the motion of the ball when it reaches the apex, so maximum height. So we know that acceleration is always 9.8, or you can say 10, 9.8 downward, and then when it reaches the maximum height, the velocity is 0, right? There's no horizontal because you throw straight up, so that means velocity is 0. There's no vertical component or horizontal component, so those are both of them answer. Okay, that's it for this video.